Standard deviation is a number that represents how far on average your data is from the mean. Because you can have a bunch of data that's all clustered near the mean, and it will be the same mean as data that's very far spread out. However, standard deviation says to you all of your data is very close to the mean versus all of your data is very far. So if you have a standard deviation of 0.5, that means that most of your data is within half a point from your mean. As opposed to if you have a standard deviation that's 5, it might say that your data is more spread out because most of your data on average is 5 points away from your mean. So that's what standard deviation tells you. And we can go through a simple set of steps that allows us to find the standard deviation. The steps are simple. The first thing we do is we find the mean, and we label the mean as x bar. Next, we subtract the mean from each data point, so that would look like x minus x bar. Then we square each difference. Add up the squares. We're going to divide the sum by 1 less than the amount of data, and then we are going to take the square root. The easiest way to do this is to create a chart to organize your information. So let's say we want to find the standard deviation of this data, 7, 5, 12, 7, 9, and 10. So the way we set up our chart is going to look as follows. In the first column, we're going to have our x, and in this case, our x's are 7, 5, 12, 7, 9, and 10. They really can be put in any order that we want. And then in this column, we're going to have our x minus x bar. Now, obviously, in order to do this, we need to first go ahead and find the mean. In this case, our mean is approximately, and again, I'm just approximating, 8.3. So next I go ahead and I fill in the chart, subtracting the mean from every one of my values. As you can see, I've gone ahead and filled that in here. Notice I have written the negatives in, but because of the next step, the negatives are not really going to matter, because the third step is we are going to square each of these differences. So we're going to do x minus x bar and then square it. As you can see, I have filled in each of the squares here. The next step after we square each of the differences is we go ahead and we add up the sum of all of them, and I'm going to put that sum down here, and the sum of all of these squares is 31.34. Now the next thing we need to do is we need to take 31.34 and we need to divide it by 1 less than the amount of numbers we have. We had 6 numbers in our problem, so we're going to actually divide this by 5, and we're going to get 6.268. Now, a lot of students want to stop here and say, okay, we're done, and they forget about the very last step, but the fact is this number here is called the variance. This is not the standard deviation. In order to find the standard deviation, you need to do one further step, and that last step is to go ahead and take the square root of the variance, which is the square root of 6.268. And when we take that square root, we get approximately 2.5. That is the answer to our problem. That is the standard deviation. And again, what that means is if you look at all of your data here, it's saying that in comparison with the mean, which we found to be 8.3, most of those data points, all of those data points are on average 2.5 spaces away from our mean.